In question 18, we have a stationary sound wave that is formed inside an open tube of length 0.68 meters. We have a small microphone that is inserted into the tube and it detects a first note at a distance of 0.17 at the end. So we know that this is a note and this is an antinote and this is also an antinote because it's an open pipe. The microphone is then fixed in this position. The question tells us that the speed of sound is 340 meters per second, and the question then tells us that the frequency of the signal generator is now increased until the microphone detects a note once more. So basically we achieve resonance again. And we are asked what is this new frequency. Now you must understand that we are insisting that this point of 0.17 is a note. So the biggest wave that we can fit inside here is going to look like this, where this is 1/4 of a wave. So you must understand that we have to treat this as a open-close sort of situation. Now, bearing in mind that 0.17 is 1/4 that of 0.68, okay, we can check whether or not if we copy and pasted this 1/4 wavelengths all the way to the other side, whether or not we'll get a antinote at the other end. So copying and pasting, we have 1 more quarter, 2 more quarters, and 3 more quarters. So we are safe. We have an antinote at the other end. So this is the biggest wave that we can fit inside. And thus we know that 0.17 happens to be 1/4 of a wavelength, because you can see we can fit 1/4, 2 quarters, 3 quarters, 4 quarters inside this length of 0.68. And thus, the wavelength for this biggest wave that we can fit in is going to be 0.68 meters. Now, if we increase the frequency, this means that the wavelength will be shorter. However, because I'm insisting that this is an antinote and this is a note, as mentioned before, we have to treat the first quarter as an open closed pipe. This means that my next higher order is going to look like so. So checking if I copied and pasted this all the way to the other end, whether or not this side gives me an antinote, I'll have another 3 quarters, another 3 quarters, and another 3 quarters. So as you can see, I'm safe. So this would mean that 0.17 is equal to 3 quarters of a wavelength. So this means that lambda is going to be 0.68 over 3. Because we already know that the initial frequency was 340 meters per second, and because V is equal to F lambda, we can substitute it in 0.68 over 3 equals to 340, and therefore we have a value of 1500 Hertz.